Law of sines is sine of A over side A equals sine of B over side C. Sine of B over side B equals sine of C over side C. Does that look familiar? How are the angle A and side A, how are they related to each other? Yeah, they're always opposite of each other. So every single time when we have an angle on the side measure that are represented by the same letter, they're always opposite of each other. One other thing here is, do you need all three of these to make an equation? No, you just need two of them. So in order to use the law of sines, you need to have at least one angle and side opposite that you know, and then any other missing information. And as long as you have that, you can solve it. So we are going to solve this triangle ABC. A is equal to 63 degrees. Side A is 15 and side B is 10. So here's A is 63 degrees, side A is 15, and side B is 10. So we want to solve, so we're going to find all the missing pieces. So first off, what are all the missing pieces? So what aren't we given? Okay, so we are not given angle B, angle C, or side C. So those are the three pieces of information that we need to find. Okay, so to find those, we're going to set up a law of sines. Now, law of sines is used for what type of triangles? Do they have to have a special, like a right angle? No. These are used for triangles that do not have a right angle. Okay, so anytime you have a triangle that does not have a right angle, we can use law of sines. So which angle and side opposite do we know? We know side A and angle A. So we can set up our law of sines. So we can start off by saying sine of 63 over side of 15 is equal to, sine of B over side B, which is 10. Okay. Hopefully you guys got to the point last year when you see a proportion, you should be able to solve for the missing value right away. If you're unable to do that, you can start by multiplying the denominators to get it alone. But how can we get sine of B alone here?
Multiply.
Okay, so we can just multiply this by 10. So if we multiply by 10, this is now gone and our sine of B is alone. So we'll take 10 times our sine of 63 and divide that by 15. That gives us our sine of angle B. So what do you end up getting for this value when you... Five, 9, 4, 0, 0, right, and so on and so forth. Now this is what sine of B is, and we want to know the angle measure. So how do we get an angle measure out of this? Yeah, the inverse sine. So we'll take the inverse sine of that value. Okay, try it again if you didn't get it. Now, one other thing, when you are doing this, you need to make sure you close your parentheses after the sign. Okay, so the parentheses must be closed. If they're not closed, you will not get the correct answer. And the other thing is when you do the inverse sign, you want to use that answer when you do it. So most of you will have to use your answer button.
Why do we do the inverse sign?
Because we're looking for the angle. So you have to use your answer button. If you round these off, you will get incorrect angle measures. Okay? Yep. Mm-hmm. Yeah, so we should get 36.4 ultimately for the angle B. Are you closing the parentheses after the 63? And are you in degrees are the two questions.
No, I had it.
Okay. If you're having trouble getting that, I will come around and help you later during work time. So now, we always do angles to the nearest degree. So what would this be to the nearest degree? Yeah, 36. Now, one other thing is we do want to keep our answers as exact as possible. So when you get the angle measure in your calculator, you don't want to clear it out. You just want to leave it in there. Okay, so it should just sit in there. We now know this is 36.44 and so on, rounded to 36 degrees for our final answer. But now we want to find out what angle C is. So how can we find angle C? Yeah, so we can add 63 onto B and then do 180 minus that number. And once again, you want to keep that number in your calculator. So you want to be using your answer button for this. Okay? And what do you end up getting then for angle C? So 80.55 and so on. Everyone able to get that?
You took the 36.4 plus 64.
Yeah, and this number was in your calculator. You did not clear the 36.4 and so on. You add 63 to it, and then we have to subtract it from 180 because there's 180 degrees in a triangle. And what would we round that to the nearest degree? 81. So for our final answer, we'd say it's 81 degrees. And now how can we find side C? Yeah, we're going to have to do law of sines again. Guessing and checking will not work. There's no way to guess and check this. So we have to do law of sines again. So we'd start off with the sine of 63 over 15 is equal to, this time we have the angle measure. It's the 80.55, which we're leaving in your calculator, over side C. Okay, and how would we get C alone now?
The sign of 80.
Multiplying by the sine of 80.55 will not get C alone because C is in the denominator.
Multiplying by.
Okay, so we first would start by multiplying by C, right? And then how do we get this stuff no longer attached to the C? Yeah, multiply by the reciprocal of it. So we'd multiply by 15 over the sine of 63. And we do that on both sides. So C would be equal to 15 times the sine of 80.55 and so on, divided by the sine of 63. And once again, you want to use your answer button because you should have that angle still in there. And what do you end up getting for side C? Your answer can be off by a few tenths if you do not use the exact value, if you just cut the angle measure off. A way to get around that, though, if you don't like using your answer button, is to write down about 4 decimal places, and that's usually enough to keep it. So if you don't like keeping and storing everything in your calculators, keep about 4 decimal places, and then you should be good for them. Here's 15 over 60 sine of 63. So we multiplied by 15 over sine of 63, but we still have a sine of 80.55 there, so we just left it there. As long as you had 15 divided by the sine of 63 in parentheses, and then multiplied it by, yeah. So what do you get? Yeah, 16.6. Some of these angle measures, when you use them, like for this particular problem, because the angle measure is really close to the 0.5 in the middle, it's going to be essential that you leave those decimals on there, because otherwise you're chopping off that angle. Now, if instead your angle measure here was like 36.01 degrees, yeah, you could probably just use 36 and be just fine. But especially when you get to the values in the middle, you need to keep them on there. You guys remember that? From geometry? Okay, so now we're going to go on to the Algebra 2 part of law of sines, which is our extenuating circumstances. So special cases. Okay, So we can have situations when we are given sides A and B and angle A that will give us no solutions, two solutions, or just one solution. What you saw in geometry were all of the one solution problems. So every problem you were given in geometry was guaranteed to just have one solution that worked out. That is not the case. You can't make triangles out of every option of sides, and here's why. So our angle A is in the bottom left-hand corner here, which means side A is the side opposite of it. And B, we're viewing as the side adjacent to that angle A. Now what we need to know here is something about this height. This dashed line represents the height of the triangle. Okay? And what can you tell me about heights of the triangle? What angle do they always form? They always form a 90. So this is a 90 right here. Okay, so if I wanted to find the height of this triangle, the height is my opposite side, and B for this right triangle would be my hypotenuse side, which means opposite and hypotenuse, we'd have to use sine to find the height, because it's a right angle, so we could do that. So sine of angle A would be my height, which is opposite, over my B, which is the hypotenuse. And then to solve for the height, so to find the height of that triangle, we times by B. So the height of every single triangle when we're given AB and side A is this, B sine of A. So now let's think about why that height kind of matters here. So, oh, my triangle just erased. We're going to leave everything up there. All right, so let's think about this height right here. So if our side A is shorter than that height, do you guys see how it would never actually form a triangle? No matter what we do, this side A would just sit there and swing back and forth, and we'd never actually close the figure. You guys see that? Okay, so that's saying if our side A is less than our height, which we can find out by just figuring out B sine of A. So if our side A is less than our height, we're going to have no solution. The other way how you know you have a no solution is when you set up law of sines and you go to solve for your angle that you're missing, you get an error. You try it a second time, you still get an error. That tells you also that there is no solution. Okay? Because your A, it'll just never connect. Two solutions. So once again, that is our height, okay, which is B sine of A, for the same exact argument as up here. And now our A is a length where it can connect over here, and our A can swing around and connect over here and make a triangle. So it connects in one spot and two spots. So we have two separate triangles. We have the large triangle, which is an acute one, and then we have this other triangle, which ends up being obtuse. Okay? So that gives us two solutions. Now, in order for this to work, our side A definitely has to be bigger than our height, because here our side A is going to be longer than our height, because it's got a swing. And the other part of this is it has to be less than our B, because notice our B length here has to be greater so that our A can actually come in and meet, so it can swing to those two sides. So if we have this situation, we then have two solutions. And we'll do an example for how we find the second solution. Okay. And then one solution, these are the types of problems that you would have gotten no matter what. A is equal to the height. So A is equal to B sine of A. That's one solution, and it ends up being a right triangle. Okay? Or A is greater than or equal to B. Our side A is greater than or equal to our side B. That is also one solution. And that was our solution, I think, that we had in, this example. Our A was greater than our side B, so we just ended up having that one solution which we found. So essentially what we're going to do is we want to figure out how many solutions we have first so that we know what we're solving for. So what you first want to do is you want to figure out what the height is first. So when you're given these problems, you're going to figure out what B sine of A is, and then you're going to figure out which one of these four categories does it fall into. Okay. The only time you don't need to find the height is if your A is already bigger than your B. Then there's no need to, because we already know that's just one solution. All right, so we're going to try an example here, and we're going to see which category it falls into, and then go ahead and solve it. So here's our example. Angle A is 25 degrees, side A is 5, and side B is 10. So first off, is our side A bigger than our side B? No. Okay, so it's not bigger than our side B. So we know that we don't have this situation. So we need to find the height. So we need to figure out what B sine of A is. So 10 times the sine of 25. What do we end up getting for 10 times the sine of 25? Yeah, we get 4.2. Okay, so now we want to figure out the order that these values go in. So what's our largest value up there between B, A, and the height? B. Okay, so B is our biggest value. And then what's our next biggest? A. And then what's our smallest? The height. So here, our A, our side A, is falling in between our side B and our height. Okay, so let's see. So which of these situations has our A falling in between our side B and our height? Yeah, two solutions right here. See here, side A is in between our side B and our height. So that means we have two solutions. So we're going to have to solve for two separate triangles. So what we're going to do is we're just going to solve for the first one, just 100% like normal. Okay? So how can we set this up using law of sines? And what can we find first? So angle A is 25 degrees, side A is 5, and side B is 10. How can we set this up using law of sines? Sine of 25 over 5 equals sine of, what angle would this be? Yeah, sine of B, because you know side B is 10. If you need to draw the triangle out, you can. Okay, there's really no need to, though, when we have all the variables. So that'll give us angle B. And then what's the other information that we need from this triangle? Yep, our C, our angle C and our side C. So we should have those pieces of information. Okay, so how can we solve this for sine of B? All right, so we're going to multiply by 10. So we'll take 10 times the sine of 25 and divide it by 5. That should give us our sine of B. What do we get? 0 point what? Yeah, 8, 4, 5, 2, and so on. So that's our sine of B. So then how do we find the angle measure? Yep, the inverse sine. And what do we get for that? Okay, and let's just right now write this out to 4 decimal places so that we have it for the future, because we're going to need it for the future for this problem. Oh, yeah. You are right, 57. I skipped the 7 and wrote the 9 right away. So 57.6973. Okay, so we're just going to leave that to nearest 10,000 to the 4 decimal places so we can come back and use it a little bit later. So in our final answer for this one, what would we round our angle B to? Yeah, we'd say 58 degrees. Okay, how can we find angle C then? We know angle B, we know angle A. How can we find angle C? Okay, so we'd add 25 to this, and then we would subtract it from 180, and that would be your angle C. All right, so angle C, and once again, let's just leave this to the nearest 4. 97 point what? Yep. So in our final answer, we'd say 97 degrees. Okay, and then how are we going to find our side C now? Yeah, we have to do law of sines. So we would have sine of 25 over 5. When we're given that signs, that's the sign we're going to use for every ratio, because those are the given measurements, is equal to sine of what? C, so that 97.3027 and so on over your side C. So if you left it in your calculator, you can just use it. Do you guys all know how to solve for this, or do we need to write it out again? So what is C by itself here? How do we get C alone? Yeah, times by C and then multiply by the reciprocal. So C here would be equal to what? Yep, 5 times the sine of 97.3027 over sine of 25. We are multiplying by the reciprocal. So the reciprocal of sine of 25 over, right here, this reciprocal is 5 over sine of 25, right? So we multiply by the reciprocal. That gets this gone. Then we multiply by C, so that C is over here. And these are, they're just proportions, which, I mean, that's all they are. They're just proportions. What did you get? Yeah, good. So 11.7. So there's one triangle. So that's what we know. That's completely same thing as before. Okay, nothing different. So now let's talk about how we get the second solution. So to do that, I'm going to go back and show you on this a little bit. A couple things. So look at this inside triangle right here. What can you tell me about that triangle if both the sides are A? It's an isosceles triangle. So if both sides are A, what can you tell me about those two angles? They're the same. And what angle measure is that down there? What letter represents that angle? This is side B, so what angle is this one? This is B. So right here, this is angle B from our first part, which means this here has the same exact measurement. So how would you find this new angle B for your second triangle? Subtract from 180. Okay, so to find the new B, you would just have to take 180 times the old one. Okay, and then we work off of that number. So here, for our second triangle, we also will have three values, B, C, and C. And the first thing we're going to find is the new B, which we just found out was 180 minus our old one. And we wrote down what it was to the nearest 4 decimal places, so we have it already. So we would do 180 minus 57.6973. And so what do we get for our new angle B? I'm just going to write it with like a prime symbol. That way we have something different. We get 122.3027, so 122 degrees for our final. Now, how would we use that to get our other new angle of C? So here's one angle, 122.3. Here's our other angle, 25. How can we find the third angle of this triangle? Yeah, so we'd add it up and subtract it from 180. See, same process we were doing, just with a new angle. And what do we get for that new angle of C? 30 what? Point what? 0.69, so we'd say it was 32 degrees or 33 degrees rounded? 33. Always round to the nearest degree. And then how are we going to find our new side C? Yep, law of sines. So we would have still our sine of 25 over 5. This time is equal to sine of this new angle we just got, which is 32.6973 over our new side C. How can we get that new side C alone? What would we have? Yep, so what would we have? We'd have
5 sine of 32.6973 over 5.
yeah, over sine of 25. That's our new C. Sine times by 5 divided by. And what do we get for our other side for C? So 6.4? All right. Is everyone okay with that? Yes. We got the new B because this is an isosceles triangle. So here's our original B. So those two angles have to both be the same measurement. And so here's our new B right here. But those form a line, so we just have to subtract from 180. This new angle B is right here. That and the old one form a line, so they form 180. So we just subtract from 180. So we wrote down our original B. We left it to the 4 decimal places. And so we just used 180 minus that value to get our new one. And we use that throughout. Okay. Those are the hardest types of problems that you're going to see. So I thought we would do one of those together. Okay. And yeah, well, there's 2 solutions, so you're doing 2 problems. Okay. Exactly. So